Hi, this is Alex from devstories.eu. LiteLLM, the Universal LLM Gateway. Episode 9 of 24. Using an expensive 128K context model for every single user query is a massive waste of money. But if you default to a cheaper, smaller model instead, a user uploading a massive PDF will immediately break your application. The mechanism that resolves this tension is called context window fallbacks. You might assume fallback routing only happens after a provider API returns a failure code. That is true for general reliability fallbacks, but context limits operate differently. LiteLLM can handle prompt sizes proactively using a setting called Enable Pre-Call Checks. When you switch this boolean to true in your router configuration, the proxy stops the request and calculates the exact token count of the prompt before the provider ever sees it. Here is the key insight. You configure a primary model, such as a highly cost-effective model, and in that same configuration block, you define a context window fallbacks list pointing to a much larger model. When a new request arrives, the pre-call check executes. If the calculated token count fits within the primary model limit, the request proceeds normally. If the prompt is oversized, LiteLLM drops the primary route completely. It instantly forwards the request to the larger fallback model. This means you never receive a context length error from the upstream API. It also means you avoid the latency penalty of waiting for a provider to reject the initial payload. Your application making the request has no idea the routing changed behind the scenes. LiteLLM relies on its internal model registry to know the exact context limits for different providers. However, you might want to enforce stricter limits. Perhaps you want to trigger the fallback earlier to leave more room for generated output tokens, or perhaps you're routing to a custom deployment with a non-standard memory allocation. You handle this by overriding the max input tokens parameter directly in your model configuration. Specifying this value forces the proxy to use your custom ceiling when evaluating the pre-call check. Think about standard application traffic. A user asks a simple text question. The proxy counts 50 tokens, validates that it fits, and routes it to GPT 3.5. A few minutes later, that same user uploads a massive PDF containing 80,000 tokens. The proxy calculates the new size, sees it exceeds the GPT 3.5 limit, and automatically redirects it strictly to GPT 4-128K. Your application logic remains completely static. You only pay for the premium model when the payload actually requires it. Moving token validation out of your application code and into the proxy layer transforms your fallback strategy from a passive safety net into an active cost optimization engine. Thanks for listening. Happy coding, everyone.